So we've been looking at differentiation for the last week and a bit. We've done E and ln, we've done sine and cosine, and yesterday we looked at the chain rule. And this lesson is going to be about two really important rules, the product rule and the quotient rule. And these are helpful when we are differentiating, firstly, the product of two functions, and secondly, the quotient of two functions, i.e. the quotient is when you divide the two functions. So to kick off, let's have a look at a sample question that requires us to use the product rule. Now, part of the product rule learning is understanding when to use it. So I can see from here that we've got a function which is the product of two functions. Okay, and when I say the product, I mean the two functions have been multiplied together. Now, the two functions here that have been multiplied together are x squared and the square root of 3x minus 1. We don't have any other way to differentiate this, not at the moment. So let's get into it. We'll rewrite the function first to get rid of this square root, and we'll have a look at what the product rule is and how we use it. So this function, f of x, is x squared multiplied by 3x minus 1 to the power of a half. All right, that's what the square root does. So that's the first step. Right? And what we do here is we split this into two parts. We make one of the parts u, and we make the other part v. Right? So we're basically saying that f of x is the function u multiplied by the function v, where u equals the x squared part, and the v equals 3x minus 1 to the power of a half. Okay, so these are our two functions, u and v multiplied together make the function f of x. Now the product rule for differentiation is as follows. Now this rule is given to you in the formula book. It looks slightly different, but here's how it works. dy by dx is given by v, the second part, multiplied by the derivative of u, the first part. So we'll take v and we'll multiply it by du by dx. Then we're going to add the reverse. So we'll have u multiplied by dv by dx. So there are four parts to this product rule. There's u, there's v, there's du by dx, and there's dv by dx. So in order to do a product rule question, the first thing you're going to do is write down your u and your v, but the second thing is you're going to work out du by dx, and you're going to work out dv by dx. And this is always how I lay out my work. These four elements come together to make this rule. So u equals x squared, therefore du by dx is just 2x. v is 3x minus 1 to the power of a half. Now dv by dx, we're going to have to use the chain rule, which is why in the lesson yesterday I was saying, let's get to the point where we can do the chain rule without thinking about it. So dv by dx, let's try and apply the chain rule here. The half comes down in front of the bracket. We've got 1/2 multiplied by the 3x minus 1 to the minus a half. So we've differentiated the bracket. Once we've differentiated the bracket, we have to differentiate what's in the bracket, and we multiply those two things together. So I'm just going to create a bit more space for myself, move all this across. Apologies for the formatting here, there we go. A bit more space. So we're multiplying this, okay? So we've moved the half down, we've turned it into minus a half, and then we differentiate what's in the bracket, so we multiply by 3. So because the derivative of 3x minus 1 is just 3. So this dv by dx actually is 3 over 2 times 3x minus 1 to the power of minus a half. So then we apply the product rule. So, you know, we've used f of x here, okay, and I've used dy by dx here. It's just because this is how I remember the product rule. This is how I work with it. So I'm going to say then that f dash x, which is my derivative of f of x, is v times du by dx. So we've got this 3x minus 1 to the half, that's my v, times by 2x, which is my du dx. So I'll just write 2x times 3x minus 1 to the half. Okay, so that's my v times du dx. Doesn't matter that I've written them the other way around. This is just a kind of algebraic standard notation here. And then I'm going to do u times dv by dx. So x squared multiplied by 3 over 2 of this. So I'm going to have 3x squared over 2 multiplied by 3x minus 1 to the minus 1 half. Now, that is the derivative. That's it. We are done, essentially. Right? We found out f dash x. And again, this is another example of one where the function gets more complicated when we differentiate it. Now, if we were asked to find a gradient, we would substitute an x value into this and work out our gradient. If we were asked for an equation of a tangent, we'd then use that gradient in our y minus y1 equals mx minus x1 formula, and we would find the equation of a tangent. When we're just asked to differentiate, we need to write this in simplest form. And this is the bit that most people find challenging, right? Because applying the product rule, once you have your 4 elements, isn't too tough, but simplifying can be quite tough. So I'm going to take it in stages, right? We're looking for a highest common factor for this term and this term, right? Now, one that I can see is that I could take out x squared and I could take out half, right? So I could say this is the same as half x squared, open bracket, right? Because, sorry, not half x squared, half x, open bracket, because half x is our highest common factor, right? I can take half x out of here, I can take half x out of here. So what do I multiply half x by to get 2x? I multiply it by 4. I've still got my 3x minus 1 to the half. So multiplying half x by this gives me this. If I take half x out of here, I end up with 3x, because 3x times a half x is 3 over 2x squared. And that's multiplied by 3x minus 1 to the minus a half. But we can go further. Okay, so we've taken out our highest common factor from here and here. Now, obviously, 4 and 3x don't have any common factors, right? But 3x minus 1 to the power of a half and 3x minus 1 to the minus a half, they do have a common factor. And the common factor is the lowest power of those two things. Now, let me just write it down and I'll explain it. So this 3x minus 1 to the minus a half here, this one, that's going to be the highest common factor of these two things inside the bracket. The reason being that if we multiply 3x minus 1 to the minus a half by 3x minus 1, then we get 3x minus 1 to the plus a half. Okay. So let's do that. I'm going to multiply therefore by the 4. So I still need to multiply by that 4. And I'm going to do 3x minus 1 to the power of 1, essentially. And if we multiply half x by 4, we get 2x. If we multiply 3x minus 1 to the minus a half by 3x minus 1 to the power of 1, we get 3x minus 1 to the plus a half. So that's been factorized. So then, what do we multiply this by to get this? So what do we have to multiply 3x minus 1 to the minus a half by to get 3x times 3x minus 1 to the minus a half? It's just 3x. So this is almost completely factorized. All we've got to do now is expand this little bracket here. So we've got 12x minus 4. And then we collect the like terms inside the bracket here. (12x plus 3x). And then, we could go even further, and we could say that this is going to be x times 15x minus 4 over 2 root 3x minus 1. Now, like I said, The majority of students initially find the simplification step the most difficult. And that's to be understood. You haven't factorized something this complicated ever up to this point, and it does take practice. But the key bit really is applying the product rule and obtaining the correct derivative, because that's what's going to get your gradient, that's what's going to get your equation of tangents and normals and such like. But the simplification part at the end is what gets you the final 1 or 2 marks in a question. Takes practice. So here's a second example. Given that y equals e to the 4x sine squared 3x, show that blah, blah, blah. And that's what we're going to do. All right? So how do we start the product rule question? We write down what u is, and we write down what v is. So v is e to the 4x. Sorry, u is equal to e to the 4x. And v is sine squared 3x. That's our u times v. Now v, remember sine squared 3x is just sine 3x all squared. So we've got to differentiate those two things. So we'll find du by dx. And again, using the chain rule, or by just using that standard result that we learned last week, 4e to the 4x is what we get. And dv by dx, we will need to use the chain rule. So we'll bring the 2 down in front of the function. So we'll end up with 2 multiplied by sine 3x to the power of 1. Then we have to differentiate what's in the bracket. And we get 3 cos 3x. Remember doing the chain rule. Okay, so that 2 has to come down in front, drop the power by 1, differentiate the bracket, multiply the two things together. So we end up with 6 sine 3x cos 3x. And then our product rule. So remember, the product rule says that dy by dx, I always do write the product rule, but I'll show you a shorthand method of doing this in just a second, is v multiplied by du by dx plus u multiplied by dv by dx. Now, I'm going to use a shorthand from now on, just because it saves writing all these dv by dx's out. I'm going to say du by dx, I'm just going to say it's called u prime, so just a little apostrophe. And dv by dx is v prime. So we've got v u prime plus u v prime, right? Where u prime is this, 4e to the 4x, and v prime is this. So let's substitute in and work out what our dy by dx is. So dy by dx is v times du by dx. So it's sine squared 3x multiplied by 4e to the 4x. So I just write that as 4e to the 4x sine squared 3x plus u times v prime, or u times dv by dx. So we've got u, which is e to the 4x, times v prime here, which is 6 sine 3x cos 3x. So we end up with 6 e to the 4x sine 3x cos 3x. And that is our literal application of the product rule. So this derivative is correct. If we had an x value, we could substitute in, we could find a gradient, and we could do all of our usual stuff. We have been asked specifically to show that dy by dx can be written in this form, and that's what we're going to do. So the first thing we'll do then is we're going to say e to the 4x is a common factor. So we'll take out e to the 4x, and we'll multiply and find out what was in the bracket. So how do we turn e to the 4x into 4e to the 4x sine squared 3x? Well, we multiply by 4 sine squared 3x. How do we turn e to the 4x into this term? We multiply by 6 sine 3x cos 3x. Now, as we can see from this, and obviously we can see from this, the sine 3x is also a common factor. So we'll take that common factor out now, and we'll say e to the 4x sine 3x And we're going from this bracket here. If we take sine 3x out as a common factor, we have 4 sine 3x here, plus 6 cos 3x here. Now, interestingly, we could, to fully simplify, we could take a common factor of 2 out of this 4 and this 6. But we're not asked to. We're asked to write it specifically in this form. So we have it, e to the 4x sine 3x, check. 4 sine 3x plus 6 cos 3x. Well, 4 sine 3x plus 6 cos 3x. So that means, let's just write it the same way around as them for the sake of it. We've got 6 cos 3x plus 4 sine 3x, which means that our a value is 6 and our b value is 4. So it looks complicated, but we are just applying the product rule and the chain rules for differentiation. So now we get into the quotient rule. And much like the product rule, the quotient rule is used when we have two different functions of x, and this time our functions are being divided. So we have u divided by v. Okay, and I should write that really as y equals, just to keep my notation simple. So y is u over v, where u is a function of x, and v is a function of x. And the quotient rule for differentiation is as follows. It's very similar. So dy by dx is v multiplied by du by dx, same as before. This time I'm going to subtract u multiplied by dv by dx. Rather than add, I'm subtracting. And I'm going to take all that and I'm going to divide it by v squared. So it looks a bit more complicated. It is a bit more complicated, but it's the same idea. We still only have 4 things to write down. So let's write u equals, let's write v equals. So u equals x, it's always the numerator, and v is 2x plus 5, it's always the denominator. If we differentiate u, and we get u prime, we're going to get 1. If we differentiate v, I'm going to use v prime, and I'm just going to get 2. All right, so u prime, remember, is just du by dx. V prime is just dv by dx. I'm just trying to simplify the notation. And in fact, over here with my quotient rule, it means that I'm doing v du minus u dv, and I'm still dividing by v squared. And it just makes it look a little bit simpler. So let's apply that rule then. So dy by dx is v times du, so 1 times 2x plus 5, minus u times dv, which is the 2x, so x times 2, divided by v squared, so we've got 2x plus 5 squared. Simplify it down, 2x minus 2x is 0, so we end up with 5 over 2x plus 5 squared. And that's as simple as that one goes. No need to go any further. So that's the quotient rule for differentiation. All right, also given in the formula sheet, but hopefully, definitely, you'll get to the point where you will remember it without having to refer back to the written rule. So here we have a slightly more complicated version. All right, so I'm just going to write the quotient rule up here. Remember, the quotient rule is used when we have two functions of x, one divided by the other. All right. So the quotient rule says that dy by dx, and I'm going to use my prime notation here. So I've got v du minus u dv divided by v squared. So let's write down what we have. We have u is sine x, it's always the numerator. We have v is e to the 2x, it's always the denominator. Du by dx, or u prime, is cos x. dv by dx, or v prime, is 2e to the 2x. Again, using the chain rule, and here using what we know for sine differentiating to cosine. So dy by dx, therefore, is v du e to the 2x multiplied by cos x minus u dv 2e to the 2x multiplied by sine x. Don't need a bracket for that one. Divided by v squared, which is e to the 2x squared. Now we can simplify lots of this. E to the 2x squared is actually e to the 4x, and we can simplify the numerator. So let's do that. We look at this numerator, we can take out e to the 2x as a common factor, and then I just have cos x minus 2 sine x left, and then I've got my e to the 2x all squared, which I haven't turned into e to the 4x, simply because I can see that e to the 2x will cancel with e to the 2x on the bottom, or at least cancel one of these squareds. So we end up with cos x minus 2 sine x divided by e to the 2x. That's just cancelling this e to the 2x with one of the ones on the bottom. So there's my dy by dx. And now we're talking about as a stationary point. At a stationary point, we're just going to write that in. We have to put in that dy by dx is equal to 0. So therefore, cos x minus 2 sine x divided by e to the 2x equals 0. We can multiply both sides of this equation by e to the 2x, and we end up with cos x minus 2 sine x is equal to 0. Then we have our old friend, the trig equation. So cos x and sine x in the same equation, we're going to want to use tan. So we'll divide everything by cos x. So we end up with 1 minus 2 tan x equals 0. And therefore, tan x is going to be equal to 1/2. Let's solve that. And again, remember, whenever we use differentiation or indeed integration with sine, cosine, or any of the other trig ratios, we need to be working in radians. So calculate it quickly in radians, and we'll do arctan of 1/2, which is 0.464 to 366. The limits within which we're working are 0 to pi. So we'll do a quick check. We'll add pi radians, 180 degrees. We'll add pi radians to this. Actually, if we add pi radians to this, I can see straight away that it's going to be a number bigger than pi, isn't it? If we take pi and add something, it's going to be outside of those limits. So my x value is 0.464, correct to 3 significant figures. And there we have it. All right. That's the product rule for differentiation and the quotient rule for differentiation. And they should be straightforward. You have a u, you have v. You differentiate u, you differentiate v. You apply the correct rule, you simplify, that's the hard part, and then you work out any other questions that go with it. Okay, I'll see you in the lesson, or I'll see you in the next lesson. Hopefully the questions are not going to pose you too many problems.